Welcome back to the class which is discussing about physical quantities and measurement. In today's class, we are going to learn about density. Density of a substance is defined as its mass per unit volume. That means mathematically we can express it as density is equal to mass divided by volume. And we know that mass is the amount of matter contained in an object, whereas volume is the space occupied by an object. This simply tells how much mass is packed in a unit volume of the substance. The lightness or heaviness of an object is directly related to its density. Consider two objects having the same volume but one has a greater mass. So we can say that object with a greater mass has a higher density. Here you can see ball A and ball B. Suppose ball A has greater mass than ball B, then we can say that ball A is denser than ball B. That is, heavier objects has high density and lighter object has less density. Now let us do an activity to show that equal volumes of different substances have different masses. For that we are using an electronic weighing machine, two identical glasses, kerosene and water. Now let us fill the one glass with water and the other with kerosene up to the same level. Since we are using two identical glasses, we can say that the volume of both the glass are equal. Now we can see that the volume of water and kerosene are equal because they are occupied in the glasses which has same capacity. Is it? So let us measure the mass of water. Yes, we can see that the mass of water is 145 grams. Now let us measure the mass of kerosene. It is 105 grams. That is, water has more mass than that of kerosene, even though both of them had same volume. So we reached to a conclusion that matter in water is more densely packed than matter in kerosene. Now consider two objects having same mass but one has a smaller volume. Then we can say that the object with smaller volume has a higher density. Here we can see 1 kilogram of iron and 1 kilogram of cotton. Both has same mass, but cotton occupies more space than iron, which has same mass. Why? Because the matter within the cotton is loosely packed, whereas the matter within the iron is densely packed. So here we can say that iron is more denser than cotton, even though iron occupies less space. Do an activity to show that equal masses of different substances occupies different volume. For that, let us use the materials such as weighing machine, 1 kg standard weight and onions. Let us place the 1 kg standard weight on one side of the weighing machine. Let us keep on adding onion to the other side of the weighing machine till the pointer becomes equal. Now you can observe that the pointer is at the same level. At this moment, the 1 kilogram standard weight and onion has the same mass. But you can see the standard weight occupies only little space while onion occupied more space. Thus, we reached to a conclusion that matter in iron is more densely packed than in onion. That is why we can see that two different substances have equal masses but they occupy different volumes. In general, we can say that the substances that have high density are heavier and substances that have low density are lighter. Let us rewrite the mathematical formula for density once again. That is, density is equal to mass divided by volume. Density is symbolically expressed by the Greek letter rho. So, this letter is rho. We will be pronouncing it as RHO, rho. Mass will be expressed using small letter m and volume will be expressed using capital letter V. So, this mathematical formula can be written as rho is equal to m divided by capital V. Now, what is the SI unit of mass? Yes, it is kilogram and its symbol is kg. And the SI unit of volume is meter cube and its symbol is m cube. Thus, we got the SI unit of density as kg per meter cube, or we can write it as kg m raised to minus 3. That is, SI unit of density is kilogram per meter cube or kg m raised to minus 3. Are you remembering the CGS unit that we have learned in 6th standard? Yes, it is centimeter gram seconds. So, in CGS unit, what is the unit of density? For finding the CGS unit of density, first of all we have to write the CGS unit of mass. What is the CGS unit of mass? Yes, it is gram. And the CGS unit of volume is centimeter cube. Thus we got the CGS unit of density as gram per centimeter cube or G centimeter raised to minus 3. That is, for finding the unit of density, we have to know the unit of mass and unit of volume. Now let us see the relationship between CGS unit and SI unit of density. Let us write the CGS unit of density, that is gram per centimeter cube. It can be written as gram divided by centimeter cube. It is same as 1 gram divided by 1 centimeter cube. Let us write it as the first equation. We know that 1 kilogram is equal to 1000 gram. Or we can say that 1 gram is equal to 1 divided by 1000 kilogram. Let us mark it as the second equation. We know that 1 meter is equal to 100 centimeter. Therefore, 1 centimeter is equal to 1 by 100 meter. So, what will be 1 centimeter cube? 1 centimeter cube is equal to 1 by 100 meter all cube. That is, we have to multiply 1 meter 3 times and 100 also 3 times. That is 1 meter into 1 meter into 1 meter divided by 100 into 100 into 100. So we will get 1 centimeter cube is equal to 1 meter cube divided by 10 lakh. How we got 10 lakh? We know that this 100 into 100 into 100. There we can see 6 zeros. That 6 zeros we wrote along with the 1. And let us mark it as the third equation. Now let us substitute the second and third equations in the first equation. What is the first equation? That is 1 gram divided by 1 centimeter cube. And in second equation we have seen that 1 gram is equal to 1 kilogram by 1000. And in third equation we have seen that 1 centimeter cube is equal to 1 meter cube divided by 10 lakh. So we just substituted it. It can be written as 1 kilogram divided by 1000 divided by 1 meter cube divided by 10 lakh. This can also be written like this: 1 kilogram divided by 1000, and we can write like 10 lakh divided by 1 meter cube. But for writing like this, the symbol should be multiplication symbol. This 1 kilogram by 1000 divided by 1 meter cube divided by 10 lakh is same as 1 kilogram by 1000 multiplied with 10 lakh divided by 1 meter cube. Now we can see that 3 zeros in 1000. We will cancel that 3 zeros in 1000 with the 3 zeros in 10 lakh. Thus we will get 1000 kilogram divided by 1 meter cube. Thus we will get 1 gram per centimeter cube as 1000 kilogram per meter cube. So now we got the relationship between CGS and SI unit of density.